Hello YouTube, this is Jessica from STEM APKs. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. As you remember, in the last tutorial, I showed you how to use my a test writer, a reader and writer that you can actually read your cards, NFC cards, MIFARE cards, whatever you want to call them, and I show you how to get a card ready, place the card near reader. So let's test the keys first. And you can see test the keys. Now I'm gonna read the card. So it gives me the UID number, as you can see right there. And it's right there as well. And I can write into the card and I show you how to do that. So just do hello, spelled, so you know that it's real. And then just write to the card, and then it wrote it, and now we're going to be able to read it, and there it is. So I show you how to do that, all of that stuff in the last tutorial. In this tutorial, we're going to dig a little bit deeper and see and explain how is this happening under the hood. This is the physical pins laid out that is found on the Raspberry Pi. And remember, when you're talking about the pins, you're talking there's a distinction between the two. You have the physical pins, and these are the pins that you see here. There's one, these are odd, even. So it's 1, 3, 5, 7, and so on. And then this is 2, 4, 6, 8, 10, 12, and so on. As you can see there, even, odd. But you also have what is called the Broadcom BCM pinout, and so Rust tends to use BCM. A lot of the code that you will find in some of the crates will be using BCM. So I'm trying, if you see it, and if you see certain pins that don't make any sense, remember this because they might be using BCM. And in my code, I make comments where I'm using BCM and where I'm using physical pins because that's the issue. When you're dealing with Rust, you're going to be dealing with BCMs in some situations under the hood. You're not going to see it, but you might see it in the code and it will throw you off. Why am I bringing this up? Because when I talk about here, where you're going to be um, hooking your jumper wires, female to female jumper wires, and I gave you here the pins. These are physical pins. These are not Broadcom pins, okay? So make sure that you know that. And if you know where these numbers, SDA, SCK, this is where it's coming from. These pins right there, so you can see if you see ACC, SDA, SCK, master out, slave in, MOSI, MISO, master in, slaved out, interrupt, ground, and voltage and all that. These are the pins that you have to. These are the ones that I'm referring to, so you know. So it's nice and easy. All you need to do is just put your female jumper wire right there and hook that one to the physical pin 24 on the Raspberry Pi, which would be this one right there, this guy right there. And just follow along. Remember, the most important ones, do not fry your Pi. This is 3.3 and this is 5 volts. You're getting 5 volts from the Pi. If you hook into this pin instead of this pin, you will fry your Pi. So don't do that. And they're right next to each other, so it's very easy to make that mistake. Don't do that. GPIO pins, general purpose input output pins, can only handle up to 3.3. And there's 5 volts as for other stuff, not for this stuff that we're doing. Just use 3.3. Remember that. And I think that's one thing that I wanted to tell you, but I also wanted to mention something else. This is what the pinout is going to look like when you hook them up. It's using fritzing that I got from this gentleman that did this tutorial. And this is the where, oh, okay. These are big question because I'm using, as I mentioned in my last tutorial, I'm using a Python bridge. And there's a reason why I'm using the Python bridge. There's the NXP, when you hear about MIFARE and when you hear about the MFRC chip, this is the chip from NXP, the original chip. They came out with this chip many years ago. Now they have many variations out of these other versions of the same chip. But what's going on is that a lot of the readers out there in the wild and a lot of the cards out there in the wild, like these cards that you see here that you can buy them on the internet and Amazon for whatever price, very inexpensive, coming mostly from China. These are clone cards that use the same technology. They're clones based on the original genuine NXP chip, but will be issues with the libraries. So some of the times, some of the libraries out there are NXP libraries that function properly. They were designed to work properly with the NXP chip, not with clones. The clones have workarounds to be able to use the same functionality, but you will find certain distinctions, and you're gonna find that sometimes the code that you're writing Rust will not match with some of the clone stuff out there in the wild. And I had to go through these because I was getting funky errors and I couldn't figure out why. Well, that's the reason. There's some of the Python libraries, especially simple MFRC522, the simple, just in case you don't know what I'm talking about, when you work with the Raspberry Pi and you work in Python world, Python ecosystem, you're more likely will be using this library right here. And this is mostly the library that you're going to bring when you import MFRC522. More likely, this is what you're going to be bringing in. They're very good working with the clones, and they do even a better job than doing the Rust that is using the genuine NXP. There are timing issues, there are protocol implementation issues, differences, there are register addresses differences because with the keys and the blocks. So that's why I created a bridge, a Python bridge between the Rust code, is this guy right there, Python bridge, and Python uh, wrapper. I had to create a wrapper that is bringing this guy in because they do, like I said, they're better compatible with the clone cards out there in the wild. So you're gonna see, that's why I'm bringing in Python. You're gonna see that most of the code, 90% of the code, 95% of the code is Rust, but I'm using that bridge right there just to make our lives easier because when you try to implement this yourself, trust me, I went through this and it's a world of pain because what I said, the timing differences, protocol implementation differences, and register addresses differences, and it will create all kinds of. I don't want to put you through that, so that's why we came out with this Python bridge. So that's basically what's going on under the hood, so you know. And also another thing that I wanted to mention, this is what the chip is, the from the NXP is following the you're gonna see sometimes the ISO 14443 from ISO, the protocol that this you're gonna see sometimes you're gonna see part one. These are the physical characteristics, RF frequency and signal interface, anti-collision, and transmission protocol. This is where this is coming from, and you're gonna see it in my code. When I start talking about register addresses and all of this stuff, this is what that is, type A and type B. Some cards are type A, some cards are type B, and mostly will be working on the 1356 megahertz RFID HF, high frequency. This is where all of that stuff is coming from. You're going to see me using proximity integrated circuit cards, proximity coupling the device. This is the reader, this is the card. They're working together hand in hand. Okay? And I just wanted to go because I don't want to just start dumping terminology, jargon that you don't know where it's coming from. This is where it's coming from. MIFARE, this is MIFARE is a trademark owned by NXP. This is where they were the ones who developed it, but there's a tons of stuff out there that is based on their technology, but it's clones in the wild. Just remember that. And also this is just the stuff that I did. Okay, so let's get it into the code. Enough talking. Now let's get into the code. This is what it looks like. This is the graphical user interface. You can do this without a graphical user interface, but there's tons of tutorials online that you can do that. So I wanted to do something that it was easier to follow using why not? Full tick. So that's why I did it this way. And that way it's cleaner. You can see what you're actually writing. You know, you can put the hello and all of that stuff. This is using the graphical user interface right there. This is the main entry point into the system. Is created into a binary directory, and I'm going to show you what that is right now. This is the libraries, RS code. These are the RFID constants. This is the hardware, MFRC522. This is the protocol, MIFARE, modules, Python bridge, UI, user interface, and the logger to create all of these to give you an idea of what's going on. What I'm going to do now, I'm going to get right into the code. I'm going to clear this and nano SRC RFID. What is it? Actually, it's the Bind test writer. And this is what the code looks like. Uh, Most of this stuff you've seen before. These are the standard libraries that you've seen me in other tutorials doing from Rust. This is the full tick stuff. This is the interrupt when you use Control C to get out of the program, so it exits gracefully. And the result is just we import the result type from the anyhow crate, which is a flexible error handling library, just handling errors and making it nice and neat so it doesn't crash. It doesn't. It works pretty good. Use log is mostly for importing all the logging functions from the log crate. And this stuff, like I said, this is a multi-producer, single consumer. This is where all the channels are being created for the threads. For the threads, message passing between threads using the channels. These guys are all working together right there, those three. This is atomic reference counting and the mutex, which is mutex mutual exclusion, something I forgot the name. But this is for thread safety. This is what makes Rust Rust, right? This is why we use Rust. That's why we love Rust. It's because of the thread safety. This is where you're spawning the threads. This is the duration. We gotta play around with the duration so that the libraries play nice with each other. The MIFARE protocol with the MFRC. We have to work with time a lot. Full text stuff to make the theme look nice and dark, nice and pretty, more modern looking. That's where that's coming from, the theme type. This is using our crates, and let me just stop this for now. Actually, this is the crates that I just showed you. This is the RFID crate directory, the UI directory, and the utils directory, and I'm bringing all of these from there. This is coming from the Python script path where the wrapper is, that I just mentioned to you, the RFID wrapper. That's where you can find it. This is the enum being created. This is implementation, the structure of the right worker threads and the messages that are doing all the work. This is the implementation of this structure. And basically, if you watch some of my other tutorials, you know exactly what's going on here. I'm trying not to make this tutorial too long. This is where all the run commands are happening, where basically, let's put it this way. It run the worker loop. And what it's doing is checking for the exit flags, and it breaks here. It breaks out from the loop if it's time to exit. Okay, this is what's going on there. Here, the match receiver right here is using a timeout base to check for commands from the user interface thread, and is you have the read command. Whatever, when you press that button, the read button, this button right there, when you do read card, this is what you're calling right here. When you do the write button, this one right there, this is what you're calling. When you do the test keys button, this is the handler that you're calling. As you can see, these are the handlers. Okay, and exit, it just breaks and it asks whether it's going to exit or not, and then it breaks out of the loop. This is the error handling that I just mentioned about. Um, Logs saying that the writer thread exited. This is the handle for the handle read. It creates the UI for display. This is what is displaying what is going to show in hexadecimal. It's going to tell you what it found. You see it right there? That's where that's coming from. Not the writer, the reader. This one right there. We see the read command and the write command. And it's going to just do an iteration. It's going to map, and it's going to go around, 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 and it's going to give you everything there in a line. And it's going to create that line right there. That's for the reader. Writer, same thing, but it's writing. It's actually writing. It's going to tell you same thing. It's doing the same thing here, but instead of reading, it's just going to write, right? So it's going to give you whatever wrote the data, and it's going to give you the IID string. Handle test keys, that's the other handler. And same thing, nothing new. This one gets now into the main, whereas this is your main. This is where is everything that you see is happening here. So it's asking whether it should exit. It's going to ask the clone. This is where the threads are playing nice with each other with the atomic reference counting and the mutual exclusion that we just talked about before. This is where that is happening. This is the app default from FLTK that is controlling the theme, and these are the message that going from the sender or TX, RX, and this is the worker TX, worker RX, and the channel that's using the MSCP that we saw before. And here's showing the window. And here is in case this is the hardware stuff with the pinouts from the Raspberry Pi, the SPI bus, serial peripheral interface bus, serial peripheral interface device, and the reset pins. And here's bringing the stuff that we talked about that from the Python script wrapper is bringing it from simple MIFARE, this guy right here. Okay, that's where that is coming from. And here, when you use Control C, it exits gracefully without crashing. New workers being created, setting up UI message handler, the redraw, and all of that good stuff that we saw before. This label, UID label setting. This basically using the messages that we saw above, and then clean up before exit and exit, and that is it. And that's basically the code that makes these the main entry point and makes everything possible that you see here. In the next tutorial, we're going to go into the constants and get more into the blocks and show you more or less what's going on under the hood for this stuff right here, and how you read the data, how you write the data, but we'll do that in the next tutorial. This is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel. I will see you next time with another tutorial. Take care.